guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we will be having a look at the basics of integration and basics only. Other topics under integration such as reverse chain rule, finding equations of curves and tangents, or finding definite integrals will not be looked at in this particular video, but will be done in a later video. So without further ado, let us begin. So since we are looking at only the basics of integration in this video, I'll be having a look at indefinite integrals. Indefinite integrals. Now there's indefinite integrals and there's definite integrals. Definite integrals is when you have what you want to integrate has certain bounds. Like as we all know, the sign for integration is something like this. And how do you know it's a definite integral? Is when you have numbers at the bottom and the top over here and over here. So let's say you have 4 over here and 6 over here. That means whatever your equation is in here, let's say equation is y, once you integrate it, you substitute these values correspondingly and then subtract from each other. However, we do not need to bother ourselves with this in this video because this will be done in a later video. Now, what is integration to begin with? Integration can be said as reverse differentiation. If you're not comfortable with differentiation, you can look at my playlist of differentiation where there are various videos on how you can apply differentiation to different type of problems. Now we know differentiation, let's say for example we have x squared. If we were to differentiate this, our dy dx would be 2x. Now we differentiated this, but what if we wanted to go the other way? Let's say we want to go from 2x to x squared. Then what we would say is that we would integrate 2x, and integrating 2x would give us x squared. So if I'm saying going forward is differentiation, then I can say going backwards is integration. Likewise, I can turn it around and say, let's say if I'm going forward, I'm saying that's integration, and if I'm going backwards, that's differentiation. So the two are sort of like antagonistic pairs. If one goes forward, the other is the backwards of it. If one goes backwards, the other is the forward of it. Ultimately, they both do lead. They have severe connections in between. But since we're only looking at integration in this case, we'll only focus on that. Now, looking at a basic rule of integration, let's say we have something like x raised to power a. If we are to integrate this, the rule says that this would be x raised to power a plus 1 all over a plus 1. So for example, if this was, let's say x raised to power 5, that means our integral would be x raised to power 5 plus 1 all over 5 plus 1, which is simply x raised to power 6 all over 6. So in layman terms, what integration is simply about is the opposite of differentiation. In differentiation, you multiply. Let's say if you had x power 5 and you want to differentiate this, your dy dx would be 5x raised to power 4. You take your 5 times it with the coefficient of x and subtract 1 from the power. Integration is different. You add 1 to the power, like you can see over here, we added 1 to the power, and then you divide your new power. You divide your new equation, with the new power. So like over here, x raised to power 5, add 1 to the power, that makes it x raised to power 6, and divide the whole equation by that new power. So let's just dive right into examples, since it's just basics, shouldn't be that hard to grab. first example says find the integral of x squared. Now usually they would give it in the form of dy dx equals to x squared, and then they would ask you to find y, because you know that if you integrate x squared, if you integrate dy dx, you get your y, because if you differentiate your y, you get your dy dx. But we'll just in this video say find the integral of x squared. So find the integral of x squared, let's do that. We have x squared. Always make sure that when you start to integrate, you put your sign, this sort of arrowish bracket, not sure what it's called, but yeah, integral of x squared with respect to x, right, like this dx. Then on your next line you can start your integration, which in this case would be x raised to power 3 all over 3 plus c. Now you must be wondering, where did the plus c come from? This is the speciality of indefinite integral. When it's indefinite integration, you always add a constant when you integrate. Now the reason this is done is because, as I said, they would give you an equation of a curve, like let's say y, and they would give you dy dx, which is x squared. They would now ask you to find the equation of the curve, and you would now integrate your dy dx to get the equation, and you would now add c. So you now have something like y equals to x raised to power 3 over 3 plus c. And in 99% of all scenarios, the question will give you a coordinate. Let's say 2, 1. This is your x coordinate and this is your y coordinate. Then you would be required to plug in those coordinates in the respective y and x over here to find the value of c, which in this case would be your y-intercept. That's the main reason we add c in indefinite integrals. And often a lot of students do lose marks by omitting the c, which is basically silly mistake. So always make sure that you add your c. However, when it's definite integration, there's no need for adding c. That will be explained in another video. So on to the next example. This one I have says integrate x raised to power 9. Okay, so integrating this, we have x raised to power 9 with respect to x. You add 1 to the power, so x raised to power 10, because 9 plus 1 is 10. Divide everything by the new power, which is 10 and plus c. As usual, make sure you have your plus c. So far so good, pretty simple. Next example I have is F7. Sorry, let's just erase this. It says to me to integrate 7. Now whenever you're asked to integrate a constant, let it be 7 or 4 or 94 or 1333, whatever the constant is, your answer is simply the constant with an x attached to it. Of course in this case plus c as well, but all you do is just attach x to that constant. So if I was to, for example, asked to integrate 999,999, if I was to integrate this, my answer would simply be 999,999x. So no matter what the constant is, just add an x to the constant to integrate it. Right, next example. I need to integrate 3x raised to power 4. So let's integrate this. 3x raised to power 4 with respect to x. This would be 3x raised to power 4 plus 1, that's 5, divided by the new power, which is 5, and this can further be simplified to 3 over 5 into x raised to power 5 plus c. Now a trick to make sure or to confirm if your answer is correct, you can always take your final integral answer and trying differentiating this. So if I was to find the derivative of that, I would do 5 times 3 over 5. 5 would cancel 5. I would have 3x raised to power 5 minus 1, that's 4. And that was the exact same question. And that was the exact same question that we had here. So that means that the integral that we found is correct. So that's one way you can quickly verify your answer once you are done with the solving part. And then again, obviously, because we have a constant here plus c, even if we were to find the derivative of this, we know that a derivative of any constant is 0. So hence you don't see anything else except 3x to the power 4 over here. Next example says find derivative of 6x plus 3. So integrating 6x plus 3 with respect to x, this would be 6x, and we know this is the power of 1, so you add one, so that would become 6x raised to the power 2 all over 2, because that's a new power, plus, since it's a constant over here, so you just add an x to it, plus 3x. And obviously this can be simplified to 3x squared plus 3x plus c, because 6 can be divided by 2 3 times, so hence you have 3x squared plus 3x plus c. Again, quickly verify your answer. Dy dx of this would be 6x plus 3, and that is exactly what we have here, so that answer is correct. Next example I have says integrate 4 over x to the power 3. Now whenever you see such type of questions whether there is a fraction involved or some sort of root involved, it's always a great idea to rewrite it. So this can be rewritten as 4x raised to the power minus 3. This makes life a lot easier. You'll just see in a minute why. So finding the integral of 4x raised to the power minus 3, this would be 4x raised to the power minus 2 all over minus 2. Why? Because since our power is minus 3 over here, we add 1 to it, that gives us minus 2, and then divide everything by that new power, which is minus 2. And this can also be simplified to minus 2x raised to the power minus 2 plus c, because 4 divided by minus 2 would give you minus over here. So minus 2x raised to the power minus 2 plus c. And that's the answer to that example. On to the next one. It tells me to find the integral of 12x cubed plus 3x squared plus 1. Okay, so finding the integral of 12x cubed plus 3x squared plus 1 with respect to x. This would be 12x raised to the power 3 plus 1, that's 4, all over the new power, which is 4 as well. Yep, 4 as well. Plus 3x, 2 plus 1 raised 2 plus 1 is 3, so 3x raised to the power 3, all over the new power, which is 3, plus x, because whenever we have a constant, we just add an x to it, and 1x is the same as x. And obviously, this can be simplified to 3x raised to the power 4 plus x raised to the power 3 plus x plus c. And that's the answer for that question. And on to the final example. This one tells me to integrate 3 root x. Now this can be rewritten as 3x raised to the power 1 over 2. Now integrating 3x raised to the power 1 over 2, I get 3x raised to the power 1 over 2 plus 1, which gives me 3 over 2 all over 3 over 2, that's the new power, and this can be simplified because 3 divided by 3 over 2 is 2, So you have 2x raised to the power 3 over 2 plus c. That's the final answer for that. Again, quickly confirm, we can find the derivative of that, so dy dx of that would be 3 over 2 times 2, that's this, we'll cancel this, we'll have 3x raised to the power 3 over 2 minus 1, that's 1 over 2. And that is the same as what we had over here in the original question. And that brings us to the end of the video. This was just the basics of integration. Obviously more complicated stuff will be done in later videos. So thank you for watching. Hopefully you enjoyed. Please do not forget to perform an LSS, that is like, share and subscribe. Also shout out to YouTube channel Angie's Diary. Really interesting stuff there. Please do go ahead and check it out. Name of that channel will be in the description of this video. Thank you for watching. Have a nice one.